One other thing that one of the students mentioned during the break, what about the book, right? So, again, this is our homepage. And I use recommended text in this course. I'm not asking you to buy any books. And by the way, oftentimes people find some free resources online that can give you access to some of these things. But these are the two classical books. They're going back, way back in history of UML and the design patterns. I hold copies of all editions of these books, starting from the first edition to the latest edition. And if there's a new edition, I'm going to buy it for my own bookshelf. And trust me, every time I run into a problem or a situation in which I ask myself, in what direction should I be going? Oftentimes I just simply tell myself, why don't you pick up one of these books and look up some things? Just look at the table of contents, open a few pages, and just to see a few maybe diagrams or just thoughts expressed in these books. So the goods are really, the books are extremely good, but they're not. You're not required to buy them. But if you have access to adequate resources, similar resources, and as I promised, I will be posting links to really good presentations on YouTube done very professionally that you can use as perfect instruction on UML and some other things. Okay, so these are the books. That's the answer to that question. So now we're going back to our set of challenges, and we said that, okay, what about deciding, right? So this is, pardon my writing here on this writing pad, deciding which features to include in your semester project. Well, I think the solution to this, right? So let me just pick maybe a different color right here, right? So the solution to this challenge, essentially deciding which features, is the quality of functional specification. Functional specification is basically a description of what the system will do, and therefore it includes all features that the system will provide, right? So if it does provide a feature, it explains how it will provide, like what the user experience is going to be. If it doesn't provide the feature, if it's not part of the functional specification, then the answer is, well, it's not part of what we discussed, right? If we have to add new features, it's the whole different story. So therefore, it's really your decision, right? And yes, it always comes with a balance. Like some things are challenging to say, oh, I also want to try this, and I also want to try something else. But interestingly, by the way, it will all become a little bit more clear when we specifically talk about the structure of functional spec, what should be part of it, what is the structure of it. But overall, it's just description of all features that the system will provide, right? And from that perspective, here's some good news for you. I will be asking you to provide a very solid design of everything, but I am not asking you to implement everything, right? So your implementation may be just a couple of use cases that demonstrate interesting features, but I'm not asking you to implement the entire system, right? So that's the answer. So don't be shy or don't worry. You can go wild with describing the feature formally and doing some really good work on functional specification. And by the time we actually do write implementation, do write code, you just pick maybe a couple of these features and write some prototyping, like implement, make them work, make them demonstrable on the actual computer screen or whatever gadget you may be using, okay? Right? So that's good news. Not all of it has to be written in code in the actual implementation of the application, right? Only selective parts. However, the design should be, kind of optimistically go over, all essential features. All right. So that is actually answering this other challenge about the implementation. And now so this was like this was more like 1A and this is 1B, GUI, right? Graphical user interface. Is it hard to write graphical user interface? Probably not. Under condition. And the condition is that if you don't go overboard, if you design really simple screens, and you should design a very simple, very consistent user interface that just includes features that you feel comfortable with, like clicking a button and opening another window, right? Or entering text in a text box and checking whether it's empty, whether the user actually has typed something in. I don't see this as a big challenge. And by the way, the good news is that I will present graphical user interface early on in our class. I will go over some examples. I will write some code on my own so you can see how it's done and how you feel about it. So hopefully this is not a big drawback or setback in terms of what you have to do, right? Hopefully not. Plus, I would give it less importance. I think more important is to actually start working on business model, on business objects, on interaction between different parts, aspects such as if you need to store some information on disk, how you do that, all right? And then essentially attaching some kind of user interface to it and making it all visible, right? So that's the thing. If this was 1A and 1B, there's also 1C about the implementation, yet another thing. As we were discussing the natural flow of progression, take a look at business requirements, write functional specification, finalize your functional specification describing all features with your instructor, get a green light to go forward with it, design class diagrams, do analysis of states of objects, and so forth and so forth, and finally feel like now I'm totally ready to write some code. Unfortunately, that's not the way it works. Unfortunately, the time is very compressed. So, speaking of implementation, my suggestion would be start reading business description and start writing some code today or tomorrow or next week, okay? Start writing code, because the code does take time. Code writing takes some time. I will tell you, I just finished version 1 of one project which started in December 2014, and I thought I will be done with that project in the midst of January 2015. Well, guess what? I was done with it this January, okay? So it's perhaps when I have time, if I do have time, I'll show you some of it at some point. But just giving you an example. And I fairly worked very hard during summer where I didn't teach any courses during that time. But coding takes time, okay? Regardless, especially a level of the complexity at which we're going to be working, it's going to be taking time. So despite this ideal picture that we're trying to draw, to say, oh, we're just going to formally analyze everything. You need to start writing code right away. You need to basically experiment. Just ask yourself, what if I wanted to create an object which runs on a separate thread of execution? How would I do this? Can I write this? Can I visualize that work? Like print something on some screen, or display some text in a gadget, or maybe a timestamp, I don't know, whatever you want to experiment with, because you feel like this is going to be important for what you're going to be doing, what you're going to be contributing to this application at the end. You need to start doing this early, right? So you should have an urge to write code in this class. Then you're going to do great. If you postpone everything till last week in April to start writing code, it's very hard proposition, really hard proposition, just simply not enough. And you know how pressure is building towards the finals and other courses and all kinds of challenges in life. So good advice, start writing code early, regardless whether it's going to be actually used or not, but you have to focus your attention on that aspect a lot.